Hello, calculus fans. All right, let's evaluate the integral from 0 to 1 of x log x dx. All right, there's a discontinuity at x equals 0 because log of 0 is undefined. So we have to rewrite this as a limit. I want you to make sure to keep this in mind, that there really is no choice in the matter, that if you run into an improper integral, it must be rewritten as a limit. All right, so our integral is going to be the limit as m approaches 0 from the positive side of the integral from m to 1 of x log x dx. And this is a job for integration by parts. According to the detail rule, well, what do we got? We have an algebraic and we have a log function. So the log function is going to be our u and the algebraic is going to be our dv. So u is log, dv is x dx. So du is 1 over x dx, and v is 1/2 x squared. All right, if we plug everything into our integration by parts formula, we've got uv minus the integral of v du. Notice, as usual, I've got bounds here, and we're still considering this as a limit. And so we have to write all these things in place as part of our calculation. All right, so if we simplify our integral, the x's cancels, we'll bring the 1/2 outside the integral. And now that's an easy integral. That part just ends up being 1/4 x squared. So we're doing a limit as m approaches 0 of 1/2 x squared log x minus 1/4 x squared. This is evaluated from m to 1. Okay, now we're going to plug everything in. So for the upper limit, then we'll get 1/2 times 1 squared log 1 minus 1/4 1 squared. And then for the lower bound, when we plug in the m, we'll have minus 1/2 m squared log m plus 1/4 m squared. That plus at the end is the minus minus. Okay, now let's try to figure out what we've got in each one of these terms. The first term is 0. Log of 1 is 0. The last term, this piece here, goes to 0 in the limit as m goes to 0. And then we've got some number here. We've got negative 1/4. So really, what we have to worry about is this third term. The third term is what we're going to have to deal with the limit. So if we look at the limit as m approaches 0 of minus 1/2 m squared log m, that's of type 0 times infinity. Log m is going to minus infinity as m approaches 0 from the positive side. And then, of course, the m squared is going to 0. So we're going to need to use L'Hopital's rule. And, of course, along the way, we have to use a little algebra to get that to work out to use L'Hopital's rule. Okay, so let's just evaluate the limit of that third term. So we'll move things around. The m squared gets moved down into the denominator to make it into m to the minus 2. And now this is of type infinity over infinity, and so we can use L'Hopital's rule on this. So the derivative at the top will be minus 1 over 2m. The derivative at the bottom is negative 2m to the minus 3. Some more algebra. You move things around. The minus signs cancel. The 2's get collected together. We end up with m squared over 4. Now we can just plug in 0 into this, and we get 0. So if we go back to the limit, the first term was 0, the last term went to 0. We've now proved that the third term goes to 0. So the only thing we have left is the minus 1/4 in the second term. And so we can say that the integral from 0 to 1 of x log x dx is equal to negative 1/4. That means the integral is convergent, and it converges to negative 1/4. Okay, that's all for now.